All right, so this is 114, and they want us to use our end behavior rules to sketch a graph. I don't know why it says turning point right there. So let's just really quick refresh those end behavior rules. It's on a previous page. You don't have to write it down. The first step is always looking at your leading coefficient, so the number that comes in front of the whole function, and that will tell you something. So if the leading coefficient is positive, the right side, it wants to go up. If it's negative, the right side is sad and it goes down. So the leading coefficient, you do that work first. Step 2, you look at the degree of your function. So a quadratic is an even degree, x squared. A cubic is an odd degree, x cubed, x to the 4th, x to the 6th. If the degree is even, then the ends go in the same direction, right? Like a quadratic, they both go up. If it's odd, they go in opposite directions, one up and one down. So that is something that you either need to memorize or kind of derive in your head, thinking of your like quadratic functions, cubic functions. So now this is saying my degree is even. So I want to picture in my brain, okay, even degree is like a quadratic. They both have to go up or they both have to go down. My leading coefficient is positive. So what's it going to look like? Right, if this was a quadratic, it would just be going up. It also could be a like quartic function, maybe a W, where they both go up. So anything that satisfies those characteristics. Okay, now the degree is odd. So picture in your brain, okay, one up, one down, but I have to figure out which one goes in which direction. The leading coefficient is negative this time. So the right side of the graph has to go down. So then draw something so that the left side of the graph goes up. A linear function would also work. So linear or cubic, one up, one down like that, but down on the right. The right side has to go down. So end behavior, we're going to talk about a little bit more today in practice. Number 8 was practicing for you the turning point rule, which if you've forgotten, let's look at a linear function and a quadratic function. How many turning points are on a linear function? How many turning points are on a quadratic function? So linear function, quadratic function, how many turning points does it have? Linear has 0 turning points. Quadratic function has 1 turning point. It's 1 less than the degree, right? If it's cubic, it might have 0 turning points, but it could have 2 turning points. So the reason they say maximum number, it might not have that many, but it could have that many. So what they want you to do in 8, I want you to try this one on your own. They want you to identify the degree. Be careful on part D, because part D is not written in standard form. See how they snuck that 9x to the 6th in there? You're going to take your degree and subtract 1, and that's your answer to these problems. So take a minute and see if you can identify the degree of each of these functions, and then basically subtract 1 to get the maximum number of turning points. So take a minute and try it on your own before I put it up. All right, so I'm talking for my video now. Part A is a linear function, so it will have 0 turning points. Part B is a cubic function, so it will have a max of 2 turning points. Part C is a quadratic, max of 1 turning point. And D is a 6th degree, so maximum of 5 turning points, 1 less than the degree. And did someone write out an equation? What would have a maximum of 4 turning points? What'd you use as your power? It has to be x to the 5th. And then if you want to put more stuff after it, you could. Plus 2x squared plus x plus 7. I mean, but whatever you put after it doesn't really matter. Just that the highest was x to the 5th. All right, so then this is the putting it all together with polynomials here. This says use a graphing calculator. We're going to pretend that we're not using a graphing calculator because I want you to practice these steps without one first. And then if you have one on the test, great. you could use the calculator. All right, so I'm going to find the x-intercepts first. Here's my factored function. So it's nice and factored for me. So what are my x-intercepts? So x-intercepts, I've got 3 x-intercepts coming out of these 3 factors. The first one is x squared. So x would have to be 0. The second one is x minus 1. So x would have to be positive 1. The last one is x plus 3. So x would have to be negative 3. So in order to graph those, you need to know your multiplicity. So multiplicity is what is the power of each of those factors. So x squared has a power of 2. Where am I? Oh. So x squared has a power of 2. 2 is even. So 0 has a multiplicity that's even. Positive 1, x minus 1 has a power of 1 that's sitting up here, but you can't really see it right now. So 1 is an odd number. So it has odd multiplicity for both positive 1 and negative 3 because of these circled purple numbers. And can someone tell me, how does the multiplicity affect the graph? What does it do on the graph at the x-intercept? Yeah. So it's going to bounce off like a quadratic, or it's going to cut through the axis like a cubic or a linear function. This is what it looks like when it's different, bouncing off and cutting through, right? So that we need to know. How do I find the y-intercept of any function? Plug in 0 for x, right? So when I plug in 0 for x, I get 0 times negative 1 times 3 is 0. So it should make sense that 0, 0 is the y-intercept. They want to know, what is the power function? For part D, that just means what's the degree of the function. And this one, my other class was struggling with. So when it's in factored form, you add together all the powers to get the degree. So the total degree is 4. But in standard form, number 10, you do not add the powers together. What is the degree for number 10? 3. So I'm not sure why all of a sudden we're confusing how to find the degree, but I want to make sure that that's really clear. Standard form, you do not add together the powers. The degree is 3. But in factored form, you add them together because it's like multiplying them all together to get to standard form. All right, the last thing that I didn't ask you up here, but that we need to know is, what does the right and left end do of this graph? So that when I'm graphing it, I know. What's the leading coefficient that's sitting out in front of this entire function? 1, positive 1. So if positive 1 is sitting there, then the right side has to go up. And we just said the degree was 4, so the left side will have to go up as well because of even degree. So that's a lot of information packed into one question. So to plot it, I'm going to plot 0, 1, and negative 3. I'm going to go up on the right and up on the left. And I have to bounce off at 0. So I'm going to cut through, bounce off, cut through. Something like that, like a W shape. It said how many turning points does it have? It would have 3 in this case. And then finding the local min or max using the calculator. I'm not going to practice that right now. I just want you to do a rough sketch. So that's the type of problem you're going to try in a minute. Kind of like, thinking of this as like an exit ticket on the next page. How would it look like if you had that information? I want to show you 10 because 10 is not in factored form. So I want to get it in factored form and then have you try to do these steps on your own. How can I factor x minus x cubed? Take out an x. X times what is left then? So if I divide each of these terms by x, this is your factoring skill, you'd have 1 and then you'd have negative x squared, right? So that is equivalent to that. This can go one step further because it's difference of squares. Even though it doesn't say x squared minus 1, 1 minus x squared is still a difference of squares. So it could factor into 1 plus x and 1 minus x when I take the square root. So see for just a couple minutes if you can take this problem and do what I just did on the last question. Find the x-intercepts and their multiplicity. Find the y-intercept.